of energy. There's mechanical, heat, electromagnetic, sound. Notes tomorrow or Wednesday. And for pre-AP, you'll be having a test on 6.1, 2, and 3 on Friday. For 8th grade science, you'll be having your test sometime next week. So first off, we want to look at energy and work. Energy and work can be calculated. We can find out how much energy something possesses by using the equation for potential energy. Gravitational potential energy is mgh, where g is always 9.8. Kinetic energy is 1/2 the mass, m, times the speed squared, and the speed is always represented with the letter v. So here's our equation. Work can be calculated by measuring force times displacement. Each one of these equations comes from the definition for each one of those things: potential energy, kinetic energy, and work. Both work and energy are measured in joules. There's a direct relationship between them, and that you can't have one without the other. And that brings us to what we call the work-energy theorem, where we can say that whatever work is done is equal to the potential energy or the kinetic energy that an object possesses. There are several different forms of energy. Remember, law of conservation of energy says you cannot create or destroy energy. It only changes form. So the first type is mechanical energy, and this is due to an object's ability to move. So when you carry your textbooks in your backpack, or you put your book from your desk to the backpack, that is mechanical energy. Thermal energy has to do with the motion of atoms themselves, their vibration. Thermal energy changes with temperature changes and changing the phase of any form of matter. So thermal energy causes changes in temperature and causes then changes in phase. Remember, phase is going from a solid to a liquid to a gas. So when we increase thermal energy, that causes the temperature to go up because it causes the particles to move faster, and that will change their state. Also, thermal energy or heat energy can be caused by friction, and friction is just two objects rubbing against each other. Electromagnetic energy is light energy, and it's transmitted through space in the form of electromagnetic waves. And we'll talk about electromagnetic spectrum in another chapter, but these examples of electromagnetic waves are gamma rays, X-rays, ultraviolet rays, infrared rays, radio waves. All of those are electromagnetic waves, microwaves, and light energy is transmitted in the form of these electromagnetic waves. Then we have sound energy. This is when sound energy is produced when an object is made to vibrate. So, for example, just me talking right now, you hear my voice, you hear the sound of my voice by the vibrations of the vocal cords. If you play an instrument, most of them cause some form of vibration, and that produces the sound. Sound energy travels out in all directions as a wave. It must have a medium to travel through, like air or water or wood or the ground. It has to have something to travel through. That's why sound does not travel in outer space, because outer space is a vacuum. Some examples of sound waves: voices, whistles, horns, any type of musical instrument. All of those things produce sound energy. Nuclear, chemical, and electrical. So those are our 7 types, 7 forms of energy. Released, a tremendous amount of energy is released in heat and the form of heat and light. Nuclear energy can also be released when 2 nuclei stick together. That means they fuse and join together. They will still release a huge amount of energy. Nuclear energy is the most concentrated form of energy. That means for the tiny, tiny, tiny little space that an atom takes up, A tremendous amount of energy can be released from that. Chemical energy, energy stored in the chemical bonds of matter. So when you have a chemical reaction like striking a match, reacting vinegar and baking soda, all of those types of things are a way to release chemical energy. So those things will either get hotter or they'll get colder or they'll change form, they'll change state, they'll release a gas, they'll release a light. Any of those things would be a way to say that chemical energy is being transferred. Electrical energy is energy produced by electrons moving through a substance. So when you turn your lights on at home, what you're doing is allowing electrons to flow through those wires in your home, and that produces the electricity that you use. Okay, so this brings us to 6.3, and in 6.3 we want to look at the law of conservation of energy, which says that energy cannot be created or destroyed. It can only be transferred. So it cannot be created or destroyed, but it can be transferred from one form to another. So the total amount of energy never changes. It only changes forms. And we saw this when we did our roller coaster lab. The most common energy conversion is between potential energy and kinetic energy. At the top of the hill, you have potential energy. At the bottom of the hill, you had kinetic energy. In an automobile or in a car, fuel is burned, and that converts chemical energy, the energy in the bonds of that gasoline, into heat energy. Heat energy is then changed into mechanical energy, which causes the motor to run. So what you have is, these should be arrows. I'm going to take these out. You should have chemical energy is transferred to heat energy, which is then transferred to mechanical energy. And energy is not destroyed, it only changes forms. Energy conversions sometimes produce unwanted or unusable forms of energy. When energy conversions take place, the total amount of energy is split between a usable form and an unusable form. Unusable forms of energy are usually heat or friction. And those things are just, they're lost. They can't be used for anything else, but it is still energy, and so it is not destroyed. Energy efficiency measures the usable energy after a conversion has taken place. Technology can improve the efficiency of energy conversions. That's why we have more energy efficient appliances. So when they're talking about an energy efficient appliance, they're talking about one that has a lot of usable energy left over after a conversion has taken place. LED lights convert almost all the electricity that goes into them into light. Very little is lost to heat. Hybrid cars increase the fuel efficiency of the car, meaning that most of the energy that goes into moving the car rather than being lost to heat or sound or friction. So we can improve energy efficiency, but no machine, and we'll get to this when we talk about simple machines, but no machine, so a car or whatever, is ever 100% efficient. You will always lose a small amount of energy, at least a small amount of energy, to some unusable form. Okay, I hope this helps to explain 6.2 and 6.3. And if you have any questions, let me know. Make sure you study all three of these and how to solve equations for your test. That should be it. Hope you have a great night.